Okay, let's do the 101 Chapter 4 Sample Test. Compare the following investments by calculating the total value of the investment after 14 years. And the amount we're going to invest is $3,500. And we're going to do a compounded weekly. So we need the compounded formula. The amount after some time is equal to the starting amount, 1 plus the interest rate divided by the number of times compounded in a year to the number of times compounded in a year times the number of years. And so the amount after 14 years, that's A of 14, not A times 14, is the starting amount of $3,500 times 1 plus the APR was 5.5%. In decimal is 0.055. Compounded weekly, so N is 52 times a year. You're going to get your interest, and we're going to have to do this 52 times for each year for 14 years. So that means we're going to do 3,500 parenthesis 1 plus 0.055 divided by 52 close parenthesis to the power. If you're using a calculator, it doesn't put it up. You have to maybe multiply this first or whatever, but 52 times 14. And we get the amount after 14 years is $7,556.11 rounded. What if it was compounded continuously at a little less? How does it compare? So the compounded continuously is the amount after some time is the starting amount, Euler's number to the interest rate, again in decimal form, times the number of years. So the starting amount is still 3,500. E to the APR is 0.055 times 14 years. And now we should get a little bit more than we had before. 3,500 e to the 0.055 times 14, and we do get slightly more. We get 7,559 and 18 cents rounded. Which account would have the greater ending balance and by how much? The compounded continuously has the bigger balance. And it's by, let's see, we would subtract the 2, so I'll take this answer minus the 7,556.11, and we get $3.07. Not a lot of difference between compounding weekly and compounding continuously, but there is a difference. Determine the APY of Part A. Now, the APY you do how much there was in the beginning, taken away from how much after year one. So you figure out the amount after 1 year minus the amount at the start over the amount at the start times 100 to make it a percent. So we'd have to do this formula with 1 instead of 14. So if I go back to my calculator and go back to that one, and that was that one there. So I'm going to select it and change my 14 to 1. And that's how much there was after 1 year. 3697. Oop, you can't see what I'm doing there. 3697 and 78 cents minus my starting amount, which was 3,500 over the starting amount times 100, and that works out to be, so I got to take 3,500 off of this, minus 3,500, 197 and 78 cents. So I do 197.78 divided by the starting amount, 3,500, and then I multiply it by 100 to get the percentage, and it's 5.65 annual percentage annual percentage yield. 5.65%. How much would have to be invested at 4% APR for 20 years to having an ending balance of 100,000? So the ending balance, A of T, is 100,000, and we have trying to figure out how much to start with, and the compound formula says 1 plus the interest rate 0.04, 4% in decimal. It doesn't say the compounding on here. So we'll have to assume then it was annual it doesn't say compounded, so we'll just have to use compounded once a year, annually. So 1 times 20. And so we have this side works out to be parenthesis 1 plus 0.04 divided by 1, which is the same thing, to the 20th. And then I would divide that into the 10,000 or 100,000. So I got 100,000 divided by that last answer, and I would have to put $45,638.69 into the account if it was compounded annually. I'd have to do a little less if it was compounded more often, but since I didn't say anything, I'm just going to do this one with compounded annually. On the test, I would give you the compounding rate if there was one. Okay. How much would a savings account have to have in it at the end of 20 years if the monthly payments are made at 150 and the account earns a 5% interest? Again, this one should be for to have 100,000 at the end. I didn't say that clearly in this sample test. Again, So we're trying to get 100,000 now, but now we're going to do it for 20 years, monthly payments. So there's a whole nother formula. And that is the amount after some time is the payment that we put in monthly times a fraction. And that fraction, let's see if I can remember. I'm afraid if I try guessing this, I'll mess it up. But I think it's the APR over N to the NT minus 1 over APR divided by N. So I better look that up real quickly here. Let's see if I can do that. That's going to be, I'm going to go with that, and then if it's wrong, I'll have to come back and fix that in my video. Okay, so I'm going to have 100,000 is what I want to get. Trying to solve for the payment, and it's times this number. And this number is, it said 5%, so 0.05 divided by, wait a minute, is it 1 plus? I do need to look that up. Where can I look that up? I'll be right back. Okay, I'm back. I've got our book. I gotta get to the right chapter. Yeah, it's the formula is 1 plus that. Yeah, that's what I was missing. All right, so it's 1 plus the APR over N, and we're doing this compounded monthly, so 12 to the 12 times 20 years minus 1 over 0.05 over 12. So I got to figure out that number. So it's a fraction. So on this calculator, I can make it a fraction and do parenthesis 1 plus 0.05 divided by 12, close parenthesis, to see, 12 times 20 is 240, to the 240, come down, minus 1, that's the numerator, and the denominator is 0.05 divided by 12. And it says I need to put in 400, no, that's this number, and I have to divide that into 100,000. So I've got the equation 100,000 equals the payment times 411.03. So I got to divide 100,000 divided by that answer, and it says the payment has to be $243.29. Not too bad if my goal was to have 100,000. I know you guys want to have in the millions, but this is probably more likely what you're going to do, something like this. $200 out of your paycheck, $250. and have a nest egg of 100,000. Hopefully you got some other kind of retirement plan going on too. How much would you have to be added to a savings account each week to have an ending balance of 100,000 in 5 years, assuming an APR of 6%? So now we're going to try to end up with 100,000 or 10,000, and we're going to make a payment each week. And so the formula will be 1 plus the APR, 6%, 0.06, done each week. So that's 52 times to the 52 times 5 years. That's times, not 52.5. Minus 1 over 0.06 over 52. So we're going to figure out this number and divide it into 10,000. So that number is going to be done similarly to that one. So I'm just going to bring that one back and go in there and change the numerator, too far up, to 6%, 52 times a year. And so 52 times 5 is the exponent. 52 times 5. And down here, 6%, 52 times a year. And this number is 303.00866, whatever. So I got to divide that into 10,000. So I'm going to go 10,000 divided by my last answer, and I get $33 into the savings account each week, and in 5 years I'll have $10,000. And the last one, if an investment returns of 2,000 returns 5,500 in 15 years, what is the total return rate? Well, the total return rate is how much you gained. So that's the 5,500 minus to 2,000 divided by how much you started with, and then times 100 to make it a percent. So in this case, if we clear this and we do 5,500 minus 2,000 is 3,500 divided by 2,000 times 100 gives us a return rate of 175% in 15 years. So I have 175% more than what I had before. So check that. So if I had 2,000 times 175% in decimals, 1.75, I gain $3,500. So I have the 2,000 plus 3,500 more, making the 5,500. That's what the total return rate over the total 15 years. Now, how much was the return rate each year? Which is called the annual return rate. Well, you get that by taking, if we knew 1 year, but we don't. So we take the final amount after 15 years divided by the initial amount. So in this case, it's for the 15 years. Then we take that to the 1/15th power. So we're taking the root, the 15th root of this, because this thing multiplied 15 times the original amount should give you the 5,500. That's kind of what's going on here. Is the amount at the end is the amount at the beginning times some interest rate. Some interest rate here. The interest rate was, we don't know, but there's some number here that 1 plus the interest rate over how many times compound. We don't know what that is, but there's some number here, call it B, to the 15th power. So we're going to take the amount at the end divided by the amount at the beginning, and that's the base to the 15th power. To get rid of that, we take it to the 1/15th power to get rid of that. And that's 100% plus the increase amount. So then we subtract 1 from that and take it times 100 to get it into percent. So what that looks like is final amount 5,500 over the 5,500 over the starting amount to the 1/15th power to get rid of doing this 15 times. And this gives you 100% plus a percentage more. We subtract 1 for there, so we get the percent increase in decimal times 100 to make it the decimal form. So the annual percentage rate is 5,500, 1 too many zeros, divided by 2,000, 2.75, to the 1/15th power. And then subtract 1, because this says it's basically 6.97% growth, 100% plus 6.97. So we take minus the 1 so that we get the decimal form, take it times 100, and we see that the annual percentage growth or gain is 6.98%. Now, I didn't do these two formulas for you. I did an annual percentage yield, so that's probably what I'll put on the test. But that's how to answer 5 the way it was written on this previously used sample test. Okay?